So here is another question on energy associated with simple harmonic motion. So it is given that a spring with a force constant of 1.6 into 10 to the power 4 Newton per meter and a mass of 0.1 kg at one of its ends has a total vibrational energy of 3.2 joules. We have to calculate the amplitude of vibration and the maximum speed or the maximum velocity. Okay. So first here for the the spring and mass arrangement which is undergoing SHM motion, let us write the SHM equation first. Okay, let it that be A sine omega t. Okay, that no initial phase angle information, so that's why simply sine omega t. Now for this we know that the kinetic energy for SHM, that is given by 1/2 k a square minus y square. A is the amplitude, y is the instantaneous position of the particle undergoing SHM. This is kinetic energy. Then potential energy, that is given by 1/2 k y square. Okay, this is the potential energy. So the total energy will be the sum of kinetic energy and potential energy, which is equal to 1/2 k a square minus y square plus 1/2 k y square. Okay, here the force constant k is given by m omega square, where m is the mass, omega is the angular frequency. So here that will be equal to 1/2 k a square. That is the total energy which is constant always throughout the whole SHM motion. The total energy, the total vibrational energy, 1/2 k square is constant. Here it is given that this constant energy value, the total vibrational energy, that is equal to how much? 3.2 joules. Okay, that implies 1/2 k a square is equal to 3.2. So here k is equal to how much? 1.6 into 10 to the power 4 Newton per meter, the spring constant. Amplitude of the oscillation, that is how much? So we have to calculate the amplitude. Okay, that is unknown, that. Okay, so here it will be a square value, that will be equal to 3.2 into 2 by k, which is equal to 1.6 into 10 to the power 4. So that implies A is equal to root over of this much, 3.2 into 2 by 1.6 into 10 to the power 4. So here 1.6, 3.2, that is 2, 2 into 2, 4, 4 into 10 to the power. So it will be coming around 0.02 meters. Okay, that is the amplitude of oscillation of the SHM motion. Then it has been asked to calculate the maximum speed. Now the maximum speed in SHM is given by omega a, where omega is the angular frequency, and we know that this angular frequency omega is equal to root over of k by m. So here k is equal to 1.6 into 10 to the power 4 Newton per meter, the force constant or the spring constant, and mass is 0.1 kg. So it will be 1.6 into 10 to the power 4 by 0.1 root over. So that is equal to the angular frequency. It is coming around 4 into 10 to the power 2 radians per second, and the maximum velocity or the speed, that is equal to 4 into 10 to the power 2 0.02, that is equal to 8 meters per second. Okay, so the two things that were asked: first, the amplitude of the vibration, which is equal to 0.02 meter, and the maximum speed or velocity, that is equal to 8 meter per second. So here this is plus minus 0.02 on either side of the equilibrium position. Okay, so this is the thing. So here is another question on energy of simple harmonic motion. So it is given that a particle of mass 0.25 kg vibrates with a time period of 2 seconds. If the greatest displacement attained by this mass or this object is 0.4 meter, find the maximum kinetic energy and the force constant. Okay. So first, for the particle executing simple harmonic motion, the displacement equation is this, as we all know, basic format. Here it is given the mass of the object is 0.25 kg, time period is 2 seconds. Okay, this, and the greatest displacement means the amplitude of SHM, that is 0.4 meter. We have to determine the maximum kinetic energy. So for determining the maximum kinetic energy, which will be as per this relationship, 1/2 mv max whole square, we have to calculate Vmax. Vmax, as we all know, for SHM is equal to omega A. Omega is not given, we have to calculate it. So we know that angular frequency is equal to 2 pi f, that is frequency in second inverse or hertz, or it is equal to 2 pi by time period t, capital T. So here it will be equal to 2 pi by 2, that is equal to pi radians per second. This Vmax simply will be equal to omega A, that is equal to pi into 0.4. Okay, so if we calculate the maximum kinetic energy, which is equal to 1/2 into mass, which is equal to 0.25, into Vmax, which is equal to pi into 0.4 whole square, and that is equal to, it is coming around 0.197. So rounding it off, it is coming around 0.2 joules. This. Then it has also been asked to find the value of the force constant. Now we know omega is equal to root over of k by m, force constant and mass. That implies omega square is equal to k by m. That implies k is equal to m omega square. So here it will be simply equal to 0.25, that is the mass, into omega square, which is pi square. Okay, that, because omega is pi, and that value, it is coming around 2.4649. So rounding it off, we can say 2.5 or like that. Okay, that's much Newton per meter, that is the force constant. So here it was asked first to calculate the maximum kinetic energy which we did here, and the force constant which we calculate here, 2.4649 Newton per meter. Okay, basic application of the various concepts related to energy associated with simple harmonic motion, in this case kinetic energy. Okay,